Planet Venus, our neighboring celestial body, boasts fascinating statistics. Let's delve into the complete explanation. Venus orbits at an average distance of around 108 million kilometers from the Sun, making it the second closest planet. With a diameter of approximately 12,104 kilometers, Venus is slightly smaller than Earth. Its mass is about 4.87 by 1024 kilograms, equivalent to 81.5% of Earth's mass. The volume of Venus measures around 928.4 million cubic kilometers, accounting for 86% of Earth's volume. Venus rotates slowly, with a rotation period of about 243 Earth days, meaning a Venusian day lasts almost 243 Earth days. Its revolution period, the time to orbit the Sun, spans approximately 225 Earth days. The surface temperature of Venus is scorching, averaging around 462 degrees Celsius. This makes Venus the hottest planet in our solar system. Its atmosphere is predominantly composed of carbon dioxide, accompanied by traces of nitrogen and other gases. The atmospheric pressure on Venus is an astonishing 92 times higher than Earth's, equivalent to around 92 bars. With a density of about 5.24 grams per cubic centimeter, Venus shares a similar density to Earth. However, its surface gravity is only about 91% of Earth's gravity. Venus lacks natural satellites, making it one of the few planets without a moon. Furthermore, its magnetosphere is considerably weaker compared to Earth's. These comprehensive statistics provide a glimpse into the intriguing nature of planet Venus. Ongoing research and space exploration missions continue to deepen our understanding of this captivating world. If humans were able to remove 95% of carbon dioxide from the planet Venus, the consequences would be significant, yet highly complex. Here are some potential outcomes. Atmospheric changes. Removing a large amount of CO2 would drastically alter the composition of Venus' atmosphere. CO2, which currently dominates the Venusian atmosphere, would be significantly reduced. This could affect the planet's thermal balance and alter atmospheric properties such as surface temperature and atmospheric pressure. Greenhouse effect. Carbon dioxide is a major greenhouse gas responsible for the global warming on Venus. Removing a substantial portion of CO2 would greatly diminish the greenhouse effect on Venus. This could result in a drastic decrease in surface temperature and extreme changes in climate. Surface conditions. Venus currently has extremely inhospitable surface conditions with high temperatures and atmospheric pressure. Removing CO2 in large quantities might potentially modify the surface characteristics of Venus, reducing the extreme temperatures and pressure. However, other factors such as other greenhouse effects, volcanism, and the planet's geological history still influence the surface conditions. Impact on potential life. Currently, no life is known to exist on Venus. However, removing a significant amount of CO2 could create opportunities for potential life in the future. Changes in climate and atmospheric conditions could create a more favorable environment for the development of life forms that may emerge in the future. It is important to note that removing 95% of CO2 from Venus is an extraordinary challenge that would require immense technology and effort. Furthermore, the long-term consequences of such changes are still not fully understood and would require further research. Please keep in mind that this scenario is purely speculative and hypothetical. The exploration and potential alteration of other planets' atmospheres are complex and futuristic endeavors that would require advancements in technology and a deep understanding of the planetary systems involved. In ancient times, civilizations such as the Egyptians, Babylonians, and ancient Greeks observed Venus as the bright morning star and the visible evening star in the sky. In the 17th century, Galileo Galilei utilized a telescope to study Venus and discovered its phases, similar to the Moon. This supported the heliocentric theory proposed by Copernicus, indicating that Venus orbits the Sun, not the Earth. The 18th century saw further advancements in understanding Venus. Scientists like Johann Schroeder and Mikhail Lomonosov conducted detailed observations, with Lomonosov proposing the presence of a thick atmosphere on Venus. The 19th century marked the era of space exploration to Venus. Missions like Mariner 2, launched by NASA in 1962, became the first to fly by Venus successfully. The Soviet Union's Venera 7, launched in 1970, achieved the monumental feat of landing on Venus' surface. In subsequent decades, a series of space missions, including Mariner, Venera, Magellan, and Venus Express, continued to explore Venus. These missions provided valuable insights into the planet's surface characteristics, atmosphere, and extreme conditions. Recent discoveries have unveiled fascinating aspects of Venus. Scientists have identified toxic gases in its atmosphere, detected potential volcanic activity, and even found indications of potential life in the Venusian clouds. As technology continues to advance and space exploration progresses, our understanding of planet Venus deepens. Researchers are constantly unraveling the mysteries of this captivating planet, shedding light on its unique characteristics and contributing to our broader knowledge of the cosmos. Currently, there is no compelling evidence of past life on the planet Venus before it became the hot and inhospitable world it is today. Based on research and observations, Venus has undergone dramatic changes over billions of years. Venus is believed to have had a different history compared to Earth. Presently, its surface temperature is scorching, and its atmospheric pressure is extremely high, making it inhospitable for life as we know it. However, in the past, Venus might have had different conditions, and some theories suggest that it could have once harbored liquid water on its surface. Studies have revealed that Venus may have experienced cooler and more watery periods in the past, which could have provided opportunities for life to develop. However, around 700 million years ago, a strong greenhouse effect, caused by an increase in CO2 concentration in Venus' atmosphere, led to drastic changes in the planet's climate and surface conditions. This resulted in an extremely powerful greenhouse effect and scorching surface temperatures, rendering it inhospitable for life. Although there is no concrete evidence of past life on Venus, further research and advanced exploration missions to the planet will help us gain a better understanding of its history and potential for life.